Good evening, everyone. I'm Vinita Anand, Assistant Professor in the Mechanical Engineering Department, SESA Engineering College, Sasaram. Today, I will be presenting a presentation on heat treatment process, which is one of the most fundamental topics in material science and mechanical engineering. We can also say that it is a bridge between the science of metallurgy and practical needs of engineering industries. So let's start. We start with the learning outcomes. That is, by the end of the session, you will be able to define what is heat treatment and explain its significance in engineering, identify the three basic stages of heat treatment, that is the heating, soaking and cooling, describe the purpose of doing heat treatment, why we are doing heat treatment on the first place. Also, we will be able to differentiate between the major processes like annealing, normalizing and hardening. We can also able to recognize real-life application industries like automotive, aerospace, and manufacturing. And most importantly, we can analyze how heat treatment changes the microstructure of metal, which control properties like fatigue resistance, wear resistance, and durability. So, let's start with the introduction. Basically, heat treatment can be defined as the controlled heating and cooling of metal and alloys in solid state to achieve desired mechanical property. So why is it so important? Metal in their raw state often do not have the right combination of hardness, toughness and ductility. Heat treatment allows us to tailor this property to match a specific application. For example, a car engine valve must be hard at the surface to resist wear but tough inside to resist impact. Also, a cutting tool must be very hard but not so brittle that it shatters. So, industries such as automobile, aerospace, construction, and tool making rely heavily on heat treatment to make their products safe and reliable. So, what are the process of heat treatment? Every heat treatment process has three fundamental stages. The first one is heating. The metal is raised to a specific temperature, usually above its critical point. The heating must be uniform to avoid thermal stresses. The second step is soaking. The metal is held at the temperature long enough for the structural changes to occur. The soaking time depends upon the thickness and the composition. And the third and the final step is cooling. This is the most decisive stage. Slow cooling produces soft structure while rapid cooling produces hard but brittle one. In short, heat treatment is all about controlling temperature and time to achieve the desired balance of property. So, what are the purpose of doing heat treatment? The purposes are multiple, like improve fatigue resistance so parts can survive repeated loading, increases toughness and reduce brittleness, preventing sudden failure, refine the grain structure, that is improving the uniformity, also enhancing the machinability or wear resistance depending on the process. In essence, heat treatment make materials fit for the service in engineering condition. Now, what are the types of heat treatment? There are basically three types of heat treatment, that is annealing, normalizing, hardening. Although it can be classified as carburizing and tempering too, but in this presentation we will focus on the three major ones, that is the annealing, normalizing and hardening. So let's start with the annealing. In this process, metal is heated above its critical temperature, soaked and then cooled very slowly, usually inside the furnace. Metal which are commonly annealed are carbon steels, alloy steels and cast iron. Conceptually, what happens? So basically in annealing, slow cooling allows atom to rearrange into a stable, low stress structure called ferrite and pearlite. This makes the metal softer and easier to work with. Applications which involve annealing are sheet metal forming, wire drawing, and preparing dies and tools. We can say that annealing is as a resetting the metal so it becomes fresh and workable again. The second one is normalizing. Similar to annealing, but here the cooling is done in steel air, not in the furnace. The material which are commonly normalized are carbon steels, alloy steels, casting, and forging. In annealing, in normalizing, cooling in air is faster than in a furnace. The structure formed is finer, giving the metal more strength and hardness compared to the annealed steel. Effects are improve machinability, refine grain size, provide uniform mechanical properties. So we can say that if annealing makes the metal soft, normalizing balances strength and toughness. Here in this slide we can see a clear comparison between the annealing and normalizing. considering the different aspect, like what is the cooling weight and medium, what is the resulting structure, what will be the hardness, what will be the ductility, and what will be the stress level. Now, if we are going for the last step, that is the hardening. So basically, in hardening, the steel is heated to 750 to 950 degrees Celsius, held for some time, and then rapidly cooled in water, which is also called as quenching, in water, oil, or brine. The soaking time depends on the thickness and the composition. Rapid cooling traps carbon atom in the lattice, transforming the structure into martensite, which is extremely hard but also brittle. Effects are increases the fatigue resistance, provide excellent wear resistance, but reduces machinability due to the hardness. This is mainly applied in like cutting tools, dies, high strength, and machine part. One also note that hardening is often followed by tempering, which slightly reduces hardness but increases toughness to make the steel usable. So here we are comparing that when we are compare the three process conceptually, annealing provide the maximum softness, which is best for forming and shaping, normalizing something like moderate hardness and strength, best for uniformity and structural component, and hardening, that is a maximum hardness and wear resistance, best for tools and high stress part. So depending on whether we want softness, balance, or extreme hardness, we choose the process accordingly. And here is the conclusion. To conclude, heat treatment is essential for tailoring properties of steel and alloy. Annealing improves softness and machinability. Hardening gives very high strength and wear ensure uniform strength. Other processes like carburizing and tampering help balance with ductility. So, without heat treatment, modern industries like automobile, aerospace, and manufacturing would not be able to produce safe, durable, and high performance product. So, thank you. That brings me to the end of the presentation on heat treatment process. Thank you for listening.